Alright, hi, my name is Minh Tran, and I'm going to be presenting my research topic on human breast milk components and their gestation periods for use as novel therapeutic agents in adults. Okay, so a little bit of background. We know that human milk is really beneficial to neonates, and they contain a wide array of proteins and biological activities, ranging from anything from antimicrobial effects to immunostimulatory functions. And breastfeeding infants early on helps their survival and develops their cognitive skills as well as their development. So I'm going to be basing my research on this knowledge to see if these components can help in adults in treatment of disease. So for example, one component of breast milk, lactoferrin, which is an iron-binding glycoprotein, has several biological functions that range from antiviral activity, and it's been shown to help inhibit HCV infections in cultured human hepatocytes. So it's been concluded that some breast milk components are more abundant and beneficial in different stages of gestation. For instance, IgA and IgM are more plentiful and beneficial in transitional milk, and IgG is more abundant in mature milk. So my final statement will be, I'm going to be conducting secondary research to determine whether specific components in human breast milk can be utilized in a medical setting to provide novel therapeutic benefits to adult individuals and the optimal gestation time to extract it for each benefit. So the purpose in my research is going to be to find the components in breast milk that may target adult diseases and help benefit them. And my second purpose is to determine the optimal time range or gestation period to extract the breast milk components to use it for each therapeutic agent. So a few limitations to this research is that because the breast milk is so complex in its biochemical process, there's a lack of reagents that are necessary to quantify all the agents that are present. Also, like everything else in the body, human breast milk is very dynamic. It depends on a lot of variables like the mother, feeding, population, gestation period. So my method is going to be secondary research that I'm going to conduct on respected epidemiologic studies that have been conducted within the last 30 years. And it's going to utilize data on the known and established components of human breast milk, and the information of these health effects on adults are going to be analyzed to determine whether they yield benefits in the overall adult body, and then I'm going to test the gestation periods that are most beneficial as well. So my first data set, it's going to be comparing the mature milk and the percent of the component within it. So we can compare the gestation periods for mature milk, transitional milk, and colostrum to see which has the most of each component. My second data set compares mammalian milk samples, so human milk compared to cow milk or goat's milk, so that we can see that human milk is most beneficial in which component. Alright, so this data set is comparing a short lactation period and a long lactation period. So in the short lactation period set, the mother's only breastfed for 2 to 6 months, and the long lactation period, the mother's breastfed for over a year. So we're trying to see the energy content and the fat content in the milk in each of these data sets. So the correlation graph over there shows that the CMT, or the hematocrit levels of fat content, increased as the duration of lactation in months increased as well. Okay, so my data set 2, it sees the effects of human milk and human milk fractions on the viability of human lung carcinoma cell line A549, and we're trying to see if human milk components can help in cell apoptosis for cancer. So in this lung carcinoma cell line, the cell viability was reduced by 92%. And so we took human breast milk and we did ion exchange chromatography in order to see which specific component was responsible for the cell apoptosis. And it was discovered to be multimeric alpha lactoalbumin. And we took that component and used it on different cell types such as human lung cell, human kidney cell, human intestine cell, in order to see its effects on the different cell types and what cell types it induces the most apoptosis in. Okay, so my future research plans, I'm going to generate data on the specific components and their mean values in colostrum, mature milk, and transitional milk. And I can combine the data to provide a clear analysis of the gestation periods that are most beneficial. And then I'm going to provide data on how each component has benefits in the healthcare field for adults, and I'm going to draw a conclusion from the data that I generate. And that's my works cited. Thank you.